Satya, Karteek, Gudipati. He's a principal software engineer at Veritas Incorporated in Dallas, Texas. And he has over 15 years of experience in software development, AI, and large-scale enterprise systems. And he's going to talk to us about making chatbots, I believe. The stage is yours.
Thank you, Thomas. Hello, everyone. How are you? I hope you have all the energy to listen to me for 30 minutes. I know this is the last session, and I'll try to keep it interesting. So basically, I am Satya Gudipati. So as Thomas gave in his intro, I have like 15 years of IT experience, and my latest projects are mostly involved around chatbots. And the enterprise chatbots are boring because they are not like your chat GPTs. So that's where my interest to think about, or I would say kind of a research started, how we can improve the chatbots and how we can adapt them to be more multilingual and along with that inclusive and also adjust to cultural tones, etc. So if you see here, most of the chatbots globally, they are trained in English. So let's talk about English for a minute. English as a language, we have multiple variants. We have the British, we have the American, and we have the Australian, the popular English slangs. And due to the Western influence, most of the cultures or nations which are developing with the Western influence are getting their own slangs, styles of English. You see, I come with a slang. I speak English. I'm from India, southern part of India. So my English will be slightly different when you compare with that of an American versus British. So even in my native language, I would mix English words when we talk in our native language. So the language is changing or converting. It's not plain or in its pure form. But the chatbots are trained on pure English. The data sets that are being trained to chatbots are pure English. In other words, chatbots only understand English in pure forms. What if somebody mixes Spanish and English? Or what if somebody mixes Arabic and English, Korean and English, Hindi and English? So how does chatbots deal with such a situation? So this paper explains in deep, and I'm going to present you that. So media services are global, and chatbots still, as we think in a pure English form. Literal translation actually misses the tone. Say, for example, in English, there are a lot of idioms, right? Like final nail on the head, hit the nail on the head, throw him under the bus, elephant in the room, pulling the leg. If you translate them as is, some of them would be attempt to murder in some languages, and some of them would be like sarcastic, disrespectful. So the chatbot has to understand the cultural tone, the emotion, and also the context. It should not translate as is. The other way around. I know many of you might have heard, you may have a lot of friends from Middle East, they would say, Inshallah, which means Allah is great. When you're translating to the other side, you cannot, there are a lot of taboos, like religious taboos, where you cannot translate the meaning as is. In simple words, you can say God is great. You cannot translate Allah is great everywhere, right? So because there are religious barriers across. So the cultural engine is very important. We have a 7-layer framework. Let's go to jump into that. So before jumping into the architecture, what is the primary thought process behind this research is, how are we going to make chatbots that are not just culturally right? They should have emotional intelligence, and also they shouldn't be biased. There should be security guardrails, safety guardrails, etc. And what are the tests? How our framework would do well, especially when there is a lot of code switching to and fro. And also how, with all these overheads, how does we deal with the latency, and also how does we perform better up to the industry standards? And the final question that came our mind was, does this really translates into a proper business case, or will it be reproductive and replaceable culturally, globally, industry-wide. So these are the 4 questions that we went across. And through this paper and through lot of research, we came up with 7-layer architecture. And this 7-layer architecture is a 7-stage pipeline that stays sub-second responses. And we did validate against 8 languages: English, Spanish, Arabic, Hindi, French, German, and Korean. And along with that, we are lucky to get it deployed into a live OTT platform, which has an NDA. We cannot, we only had agreement to test it. We cannot publicize due to the NDA agreement. It's in Southern America, and we had the results which are here to show. And let's jump to the next slide. So this is the architecture. So here, this is the pipeline that I'm talking about. Let's say this pipeline is, we did a divide and rule kind of a thing. We divide and conquer, sorry. We did a divide and conquer kind of a thing, where we had 7 layers, and each layer has a specific pinpointed task to do. And each layer is independent, and each layer and we did ablation test as well, like what if a certain layer is off and how does it impact. So the user input is the raw input that comes to the language detection and segmentation. So the language detection and segmentation is where it detects the code switching. I mean, we first detect what is the primary language, and we segment we divide the whole user input into segments and detect what is the primary language. And if the score is more than 85%, then we would respond back into the primary language. If it is of a mixed language, then we would leave it to the later parts to determine the response, and I will explain how. And next, the most important part is the translation and normalization. And here, the translation happens, and also the normalization. Let's say when you are typing non-English words, multiple folks would type it in a different spelling. So it would normalize that, and also it would give back the translation. And this translation and normalization also has a NLG, which is natural language generator, which detects the intent, and it will generate the output, and it passes on to the cultural intelligence engine. This cultural intelligence engine is the key. Is the key block. It applies the locale profiles, like based upon the primary language detection that happened in the second step. It would apply the locale profiles, and also the formality levels, and also the taboos, if there are any taboo words that are hardliners words, the F words that people use in English cannot be translated as is. And similarly, there are multiple words, vice versa. And the profanities, and then here the input will be cleaner. It would clean off all the bad or hard words, if I would say it like that. And then you have the multilingual NLU and NLG. So this is where it would understand what is the intent, and it would pick up the response for it, and it would populate the response the right way. And from there, we go to the sentiment and emotion detection. So the sentiment and emotion detection, what does it do? So let's say, let me take an example. Somebody types, say for example, my grandfather has gone. Can the chatbot respond, let's wish him good journey, or you cannot respond like that. He's no more, or he's gone. So they are like something related to death, and they have to express grief or solidarity, or it has to tone down. So the sentiment and emotion engine detects those bits and pieces, and it would double check, and it would add those. It's like you're adding bits and pieces, and you're building one block at a time. And after that, we have the bias and safety filter. This is the guardrail here, because we shouldn't be gender neutral. We shouldn't be, we shouldn't be gender bias. My bad. We shouldn't be gender bias. And the safety filter, we have to redact all the PII and other legal implicated terminologies, like we shouldn't be exposing any sensitive data, and also there shouldn't be any cuss words or anything as such. So all the bias and safety filter applies there. And finally, the message delivery. The message delivery, let's say we are like cross-platform. Every enterprise is cross-platform. You have desktop, mobile, tablet, app, and a lot of things. So based on the target platform, the message delivery would convert it into the user-friendly output, and it finally gives it back to the user. And the human in the loop is the human feedback is where the user has a chance to give thumbs up or thumbs down. So we take the response directly from the user. And if the user gives a thumbs down, it will go into a different stack where periodically a human evaluates them. And if needed, we will do a micro training for the model, or we would kind of redesign the whole intent. We do a lot of things there. So the whole latency goal is 900 milliseconds. It's just less than 1 second. And I will explain how we achieve that. So let's take this example. So a user types Hindi and English. He say like, please suggest top shows for the weekend. Maar Hindi mein. Maar means hit. In Hindi, maar means hit. So if my chatbot is not understanding it better, it would treat in a way like he's asking to hit somebody or abuse somebody. So, it may take it in a negative way. So what happens right here is, it goes to the language detection and the code switch. So the language detection and code switch would cut these into word by word, and it would detect Hindi versus English, and it would segment those, and it would score. It would give you a score, like since it is English and Hindi, it would definitely say like it's a cross code switch or mixed language. And later on the normalization happens where the grammar is corrected and the right sentence is formed. And after that, you have the cultural intelligence engine, where it says, since it is Hindi has a certain way of expressing politeness and honorifics. So it would add those, and the NLU and NLG would detect the intent. Like here, the intent is to give me the latest shows. So something related to bringing the latest shows. So the intent is recognized. And also the NLG, the subsection, the NLG would pick up the template and populate the things that are needed. And then what happens, it goes to the emotion and sentiment engine, and then it goes to the safety and bias. And then finally, if it is from desktop, it would populate a desktop template and use those and use all these details and build a response. So here are the latency budgets. You see here clearly the NLU and LRG is the primary chunk of it, followed by the translation engine. So you can expect both of them are deployed in cloud because they demand a lot of computing power and also a lot of resources. The rest of the things, we did an experimentation and we deployed them in Edge just to make sure if it works or not. It is working well. So we kind of segregated based upon the energy requirements. We deployed them into cloud and Edge. So for the implementation, these are all the if you see the LLMs that we use for translation, we use the Marie NMT, and also for the NLU we use the MBOT, and Emo React for the emojis, and Blooms we didn't mention here, but we use Blooms as well. So we use multiple open source LLMs. Previously I told you each layer is like a mini application, and each layer has its own open source LLM that it leverages out of it. So the deployed targets, as I mentioned, we deployed in both Edge and cloud, and the observabilities and all, the target is like we got less than 1 second outcome. So here are some other information, like what are the languages. So how did we test them? So we use 600 scripts, 600 interaction, that is scripted interaction, and across 8 languages. And we used a 4-week pilot project, and throughout this 4-week pilot project, we got like 9,500, approximately 9,500 interactions. And we measured all of them, and we had human raters as well. And we ran ablations as well to remove the CIE and also the code switching, and see how the CIE removal of CIE impacted the overall numbers and all, and how the removal of the code switching algorithm impacted the numbers. So these are the results overview. And though ignore those big graphs because those are the premium purchases which helped the business who helped us test this pilot project. Their numbers increased from 1,200 to 1,656. But if you look, the customer satisfaction has increased from 74 to 87, and also the first contact resolution has improved from 62 to 81. So the reason why the first contact resolution improved is this setup is recognizing the emotion and also the significance better. If let's say if there is no such a thing, right, the chatbots would either keep you in loop, or it would frustrate the user and ask for a live agent, so which would lead to escalation rates. So even the escalation rates came down from 28 to 11. So here are the numbers for the languages that we tested, and we covered 8 languages. On average, we see like strong fluency and cultural fit across, which is measurable. And by dimension, Spanish leads the fluency, Korean leads more cultural fit for our application, and Japanese has the tone. This setup has, and even the data sets that we used, maybe that has contributed more. The English, US leads the customer satisfaction. Arabic and Hindi are really challenging for us because there are a lot of idioms, and there are a lot of slangs, and we need a mega data set. So due to those limitations, we found it more challenging to implement that. The code switching handler and also the CIE delivered most of the lift for us when we are matching. So the safety and bias, as I explained earlier, let's say, so these are the safety and bias number. Like we have the 2,000 response samples across the pilot, and on a 2K stratified samples, and it hits like 0.93 F1 overall with controlled trade-off. A small like 3.8% overblock rate was seen, and most of the time it's like 1.9% misses, chiefly mixed with taboo words, and also most cases are fixed via auto rewrite, and also 8% was escalation rates. So these are more about the numbers that we put here when it comes to the safety and escalation block. So the pilot methodology, as I explained earlier, it was a 4-week pilot methodology. We randomized at the hour level, so we see both the variants of identical traffic rhythms in the morning hours versus noon and the evening, and also the weekday and the week time prime hours. And also those are the KPI numbers. We did A/B testing as well, and also we did the hourly testing as well. We compared it hourly, hour to hour, to know like are the numbers coming up properly, or to have a better in-depth analysis. So the pilot outcomes I showed earlier. So the FCR improved, and also the CSAT improved, and all the KPIs have improved, and the latency is also on par. The biggest lift came from the code switching and also the NLU handler. The ablation check, when we removed the CIE and the code switching, and the escalations increased a lot. So The full system for the full system, when the full system is on, the first contact resolution was 81 and CSAT was 87, and the cultural fit scored like 4.3 out of 5, and we removed the code switching. The first contact resolution has dropped down to 70. It lost like 11 points, and same happened. You can see like when we remove the code switching versus when we removed the cultural intelligence and removing the sentiment and emotion and also the safety policy. So the code switching and the CIE, the cultural intelligence has taken a big hit because we are removing the human touch out of the chatbot. So customers are clearly called out, like they asked for more details, or they're looping around, or they dropped. So the limitations are like the data models are not universal. Like the problem with the data set is either they are in pure language forms, or they are in the pure sense of the language. So let's say some languages has a lot of slangs. Especially from a country like India, you have multiple slangs. You have multiple slangs of Spanish as well throughout the South American nations. So we are very limited on the language sets, and also the storage, and also the audit, the legacy integration. We face some challenges and limitations there, and also the edge constraints. We did not expect. We did expect the edge to be little bit faster, but due to the certain limitations on the system resources, the edge was slightly slower than the cloud for us. That was slightly surprising, but that's the reality. And these are the other limitations. So main limits are like the TVs are latency, the remote, or they have the rich rational logging, which raises the privacy risks, and the legacy systems also challenging to integrate. And also we have like strong across those 8 languages that I showed earlier, but I cannot call this as a universal thing because I cannot deploy it everywhere. I can only deploy this in those 8 languages because we never tested it against the other data sets. And data sets, we created one data set, Cameo 8, multilingual, that is our in-house data set. It was published in IEEE data port, and we vigorously tested against that. Along with that, we have for reproducibility, we have captured the pilot data, and also we have the Docker image, and also requirements text YAML and all these configurations. We will release it when this paper gets published. Along with that, we have the licensing, everything open licensing for the Cameo CC by 4.0. The future work, we would like to expand it to maybe 25 languages, and also we want to add RAG as well as explainability into it, so that for audit purpose, we will know like why a certain intent was picked for explainability. And also instead of 4-week pilot, we would maybe plan for 8 to 12. And we want to, since we plan to expand for 25 or more languages, then there is challenge for sarcasm and also the taboo detection, etc. We already submitted the paper on the Cameo 8. It is with IEEE data descriptions. It's under review. So we are waiting on that result as well. So that's it. So you can see the world is small, and there will be a lot of chatbot evolutions, and most of the time, unfortunately, chatbots are not like chat GPTs. We don't expect them to be like super intelligent, and I hope the enterprise moves into the direction of building chatbots that are intelligent, emotionally aware, culturally aware, inclusive, and that capture the tone while maintaining bias-free and safety guardrails. Thank you everyone for your time. And if you have any questions, please.
Thanks, Satya. So we do have one question here. What are the challenges on building this multiple layer LLM model?
Sorry.
What are the challenges that you faced when building this multi-LLM model?
We did not build any in-house LLM model. Like we leveraged the open source. Like for translation, we used Marian MT and OpenNMT, and for NLU we used MBOT and BLEU, XLMR, and also for emoticons we used Blooms and EmoReact, and for sarcasm training we used Robota. All these are open source proven LLMs. We tried to put them together and build a new architecture out of it.
So they were already pre-trained. You didn't have.
They're not trained. They have those LLMs are kind of built to detect, but they are only trained on English.
Okay.
They are not trained for code switching or multi-language. So so that is the reason why we have to build up with a 7-layer architecture, so that each one has its own, because one LLM doesn't give all the output.
For each of the 7 steps, you then trained the LLM.
Yes. Against the data set, and then we deployed it.
Right. So where did you get the data to train the
data set? We created one, Cameo 8, because again, to get the data, it's really tough. It's a synthetic data, but we created like thousands of records with a lot of words using prompt engineering, and we use those data sets for training the LLMs.
Okay, cool. Any other questions from the floor here? Let's again thank our speakers for the session. Thanks again, guys.
Thank you.